Hello, folks. Welcome to the first episode of Kerbal Space Program Realism Overhaul. I'm Inublue, and I'm going to do something of a tutorial series. I'm going to show my experience within Kerbal Space Program Realism Overhaul and try to explain um, how I go about doing things. Now, it's not going to be a really good tutorial series, to be honest. It's not going to be like some of those other more nice ones out there. Um, I might actually allow quick loading just to be sure. If the Kraken strikes, you never know. Um, but it's going to be pretty. It's going to go over the basics, at least up until orbit. I'll get you in a good state. I'll teach you more or less what I know. And all of the little tips and tricks that I've picked up on the way. One of the things that I really struggled with early on is costs, always running over on costs. And I've tried several times to actually get pretty far in this program in RP1, but the thing is, I never really get to the point where I feel like I have actually accomplished enough. I always get to orbit. It's never really an issue, but it's always later on in the save when I'm really dealing with, let's see, I guess that's fine. It's always when I'm getting really low, really far in the save, excuse me, that I feel like I'm really struggling to keep up with the amount of money that I spend. So I'm going to try and do a little bit of a tutorial up until orbit, show you what you should do, more or less, things that I've learned, pitfalls that you should avoid. And then later on, and it'll be more like a regular Let's Play. And possibly down on the line, I'll do something more refined. I had been arguing with myself about whether or not I should do a refined, um, more, I don't know, I guess a more refined playthrough where people do better filming and stuff like that. But being my first ever YouTube series, I think I'd rather stick to a basic level of filming where I'm just taking in what I see, explaining things as I go, rather than trying to explain things in a voiceover afterwards. You never know. Things might change later on in the series, and we'll see how things go. But for now, it's just going to be a basic filming. So here we go. I just started. I've got 3 tabs. One you'll notice is Principia. So Principia is actually a mod that I have here installed. I'm going to try it out. We'll see. I've done a lot with Principia in regular KSP, and then I've done um, some stuff with Principia here in RSS, but it's a little bit of a complicated mod, and if I don't get things right later on, I'm just gonna abandon that. Because you can always remove Principia from your save, but you can't add it later on, so keep that in mind. And then down here, we've got the KOS. I'm going to permit all. This isn't a regular install of RP1, but most things should be the same. So here we go. We got the first steps. We got Space Center setup. So if I want to play from any different site than Cape Canaveral, I can go ahead and switch in the tracking station. To be honest, I'm going to stick with Cape Canaveral. If you can see the buildings off in the distance, these are all installations from the Canaveral pads and the RSS Cape Canaveral mods. Um, and they gave us different launch pads once we get to different weight classifications for our rockets. Um, we can choose our starting programs over here in the administration building. Then we'll be able to accept a contract after that. And then we can go ahead to the VAB and build our launch complex and assign our applicants. So in RP1, you start off at Cape Canaveral. You can go to the tracking station. I'll go ahead in there just to show you. we'll just check it out. And all over the earth, there are a number of launch sites. So you'll see we're at the highlighted green one. There's a couple U.S. launch sites: Vandenberg, Wallops, Brownsville, and White Sands. White Sands is famously where they tested the original sounding rockets and later on landed the X-15 and other X-planes. There's also the Kourou launch site, which they use for ESA in real life, and some other ones. You can also do Baikonur is right here, I believe. Yep, there we go. And then the main Chinese launch sites. Um, but for me, I'm just gonna stick to the United States. We're gonna mostly keep this a United States playthrough. I mean, I'm gonna use different rocket engines because I'm not trying to challenge myself with any limited tech sets. Ooh, actually, I did make a mistake. So I'm actually gonna exit out of this save and we will go ahead and delete this. Give me just a second. Okay, so the thing that I forgot to do is if you go down here to Kerbalism, or not Kerbalism, excuse me. If you go to RP1, where is it? Realism overhaul. So here's our tech level. Personally, I like to go all the way over to sci-fi. Now, there are some people who only do operational engines. This would be engines that it says historically flown hardware. There you go. Uh, you have operational engines, then you have prototype engines, stuff that was tested but never flown. You got some concept engines, stuff that is only a paper design and speculative, alt history, and sci-fi. So you can go from down to the bottom where you have no engines. Prototype, you have operational and prototype, and concept, you have everything below that, everything below that, everything below that. I go all the way up to sci-fi. The reason that I do that is because when you are starting out, you don't have any troubles getting the kind of engines that you need because most of the stuff starting out is going to be operational hardware. However, later on in the scene, you're going to have to fly without uh, operational hardware. You're going to want to do missions to Mars, things like that. And truly, the operational hardware can really set you back in that case because you're begging, you're pleading, you're trying to get the next engine that is barely an increase in performance over the last. And sci-fi at least gives you that stuff that you would see in, for example, The Martian and stuff like that. So I have a bunch of engine packs installed, and for that reason, I'm going to keep it on sci-fi. So after I choose my launch site, we have chosen it's Cape Canaveral. We're going to go ahead and choose our starting programs, and we'll do that in the administration building. After that, I'm going to go over to the mission control over here and grab a contract, and then we'll start looking at our first rocket. So one of the first things that you'll want to take note of before we even go in there is we have this thing called a budget. So the budget is more or less the amount of money that you make every year. And that is reflected down here in the balance. You can see we make no money. If there's parentheses around it, like up here in facilities, that means we are not making money. That's a negative balance. If there is no parentheses around it, this is technically no parentheses around it, but there's also no plus sign. If there's a plus sign, that means it is a positive balance. If there's no sign whatsoever, that means it's money that we could be getting, but we can't be getting yet. So we'll wait See down here, we've got no balance. That's another thing. That's one of the things you want to take note of. Over here, we've got Kerbal construction time, or well, a derivative of the modification called Kerbal construction time, where now we have things called integration. We've got construction, research, and this is a combined of all the three tabs. So integration, this gives us access to all of our launch sites. This shows us the vehicles that are under construction in those launch sites and how long they have to go. It also shows how much it's going to cost to complete those constructions over to the side. So that's good. If we go to construction, this will show us like when we upgrade these buildings. A lot of them are fully upgraded, but here we go with mission control. We could upgrade that one. Um, that will pop up in construction and it'll cost a certain amount of money and it'll be taken out of this construction's budget tab here. We want to keep an eye on that because constructions can cost quite a bit of money. They're not all up front. 60,000 is not being paid up front. It is a cost per day, and you can see it right there reflected when I hover over the 60,000. It's $539 or Kerbal bucks or whatever funds per day. So keep that in mind. Then we have research, and it shows us when we're expected to complete it and whatnot. It does take time. Then we have our staffing tab. We've got applicants. We can have engineers and researchers reflected in both of these tabs. You can have engineers in your hangar. You can assign them to different launch sites. We'll get to that in just a second. Researchers, they are all universal. There's only one universal researcher role. So you want to make sure that you hire the researchers that you need, but you don't want to go overboard because firing them does not give you any funding back. So you don't want to go over the researchers because your budget could be tanked because research teams do cost money. But you also don't want to go too low because you'll be really far behind on your research. Okay, with all that out of the way, I'm going to drop the budget tab and I'm going to go to the admin building. So here we are. We've got the programs update for RP1. Historically, there wasn't any of these little programs, and you used to just pull contracts. The administration building was, I mean, it was almost unused in the old RP1, but now we have a number of programs that you would have to do. So, for example, one that everybody would know is, let's see, uh, crude orbit. So this would be the early Mercury and Vostok, yeah, early Vostok missions and Mercury. And you can see here, there's a budget and it starts off low and it peaks around 1, 2, 3, 4, 5 years in. About halfway through your fifth year, the budget will peak at its maximum funding. And so that's something to be aware of. Your budget will go up and down. And in the last year, you can see it drops off precipitously. You have a deadline. It's marked by these red lines here. The deadline is something that you want to beat. You have to beat the deadline. Otherwise, you lose reputation for not getting above the deadline. So the reputation is measured in this golden number up here. The golden number is what determines your governmental subsidy. So you could make money. That was that $68 in the budget tab earlier. You could make money without having a program active, but you need to have a high reputation to do so. So if you lose reputation, you're going down. Another way to lose reputation that you truly try to avoid is killing Kerbonauts. You don't want to kill them because that loses you a lot of reputation at one time. It's big chunks of hundreds of reputation. That also loses you confidence. Confidence is the currency of programs in the new RP1. And what I mean by that is, if you can see here, we've got three types of we've got three options basically for this early crewed orbit. And if you go normal, it doesn't cost any confidence. You're just going to be getting the funding over the course of 6 years, and it's more spread out. But if you go fast, you get more funding up front. It takes less time to complete the program, and you can see the funding peaks, and it's the very end of its 3rd year of operation. So you need to complete all the objectives up here within 4 years, or you're gonna get those reputation losses like before. Breakneck is insane. So if you wanted to do breakneck, you get ridiculous amounts of funding right off the bat, and you're trying to do everything fast. But in order to get to these speeds, you have to have the confidence to do so. See how down where I click on these, it costs confidence. Normal requires no confidence. As you can see, though, when I change, these funds do not change. It's just a different amount of time that it takes to complete the contract. So you're still getting 1.4 million funds, but it's spread out differently. With that out of the way, I'm going to go ahead and select my first contracts. So one of the things that the mod authors tended to recommend, and if you look in their wiki, they'll probably recommend this as well, is that you go ahead and grab early rocket development and suborbital research. Now, both of these are really good programs. Early rocket development is pretty good for developing pre pre-orbital vehicles, stuff that would go to orbit later on. See, you got the downrange milestone of 5,000 kilometers. That's not far off from what you need to actually reach orbit. I would say once you get into the downrange of like 9,000 kilometers or 7,000 kilometers in between those two, you're getting super close to orbital velocities already. So this is a really good program for preempting those orbital missions. And then you've got suborbital research, which is more of a sounding rocket research program. The purpose of this one is to mostly go up and down, back and forth over and over again with different scientific payloads. Both of these research programs end in 6 years, and they give out the same amount of funds, 252,000. And then, but you'll notice we'll have one more program up here. This is going to be the X-Planes program. This one takes 9 years, and it costs 960,000 funds, excuse me. And you have a lot more objectives. So for example, this suborbital research, we got the Kármán line objective, which we get in the early rocket development as well. We've got the first low space film return, first low space biological experimentation, and low space advanced biological suborbital experiment. That's only 4 objectives. Same thing here. We've got complete a suborbital trajectory and return, downrange 3,000, downrange 5,000. From experience, when you have the tech that you do in this early rocket development time, the 5,000 kilometer downrange is really difficult. Really difficult. You're pushing the bounds of what is possible with early 1950s technology. So for that reason, I typically like to take this X-Planes research program. The objectives of this one are pretty simple. You have to upgrade the astronaut complex, complete the Break the Sound Barrier contract, complete Mach 2 supersonic, complete X-Planes stratospheric research, complete X-Planes high altitude, X-Planes hypersonic, and X-Planes Kármán line. So each of these, pretty self-explanatory for most of them. You want to break the sound barrier, then go Mach 2. Stratospheric is something that's usually accomplished by a U-2 lookalike plane, and high altitude is usually when we get into the Bell X-1 high flight rocket planes, X2 as well, stuff like that. Hypersonic, we're looking at X-15s, um, or possibly even Scram jets. Uh, then we got Kármán line, which is obviously the X-15. I like to pick up that and suborbital research because it gets you a lot of science starting off. So in our case, this works out perfectly. We've got 500 confidence to start off on normal mode in RP1. So I used to usually pick up this fast speed. You might pick up this normal speed if you're really worried about the timing. This one ends in 1964. And I think for this tutorial, I might just pick up the normal speed program because I'm not too worried about it. We're still getting more funds per year than the fast suborbital early rocket development, but we're going to be getting it over a longer period of time, and that'll help us with our research. It'll also help us to not have to worry about um, experiencing any delays. If we have a delay in the program or a mishap happens, then we won't have to worry about um, getting behind on our research. So I'm going to go ahead and pick that up in normal. I'm going to go to the suborbital, and to be honest, I might go with breakneck. Suborbital research does not take a long time at all, and usually what I find is that when I'm playing by myself normally, I am waiting. I usually get most of my objectives done around here in the funding timeline, and I'm waiting until I hit that peak funding so that way I can end the program. So that way I am not losing out on funds, because when you end a program, you no longer get any of these extra funds. So I think this will be good because this is roughly when I usually end my program anyways. So we'll go ahead and accept that on breakneck speed. After that, I'm going to go ahead and close this. We'll go over to mission control. And we've got a couple contracts. So we got our first launch. We'll want to climb greater than 50 meters per second. Shouldn't be too hard. And reach 1,000 meters. We'll want to break the Kármán line, which is 100 kilometers. And let's see. I guess I'll pick up this sound barrier one. Now we have our full 3 contracts. We'll go ahead into the VAB because while the sound barrier one is interesting, I think our time would be better suited in this first episode looking at rockets. It's something that everybody will be doing. X-planes is something that more advanced players might find interesting. I forgot to mention that when I was explaining the programs. I think that even though X-planes gives you more funding and X-planes helps you out with other rocket development and plane development and eventually space plane development, you don't really want to you don't want to tackle it unless you're more advanced. You have to understand a little bit about Ferrum aerospace before doing that. So here we are. We're in the VAB. We've got our probe core. This is the central hub of our vehicle. So one thing that you might find if you're not used to playing modded Kerbal Space Program, or if you're used to playing modded Kerbal Space Program, but you don't play with tweak scale, you'll notice that I can alter the size of my probe core. It is fully configurable, lengthwise, diameter wise. It's not any different. We got tweak scale installed to do that. You'll also notice that I can do the same thing with my fuel tanks. And you can do pretty precise measurements. You don't have to just do these simple one-click mouse movements. So here we go. We're going to start off. The thing that you want to note about these early rockets is they don't have to be clever. You don't have to have a parachute. You don't have to have really anything other than an engine, a probe core, and a fuel tank. For me, I think a lot of people tend to go with the Aerobee as their starter, but for me, I think that the U2 1250 is my personal favorite starter engine. That is because when you look at these engines, you'll notice a couple things. There is a huge tab here that shows you its engine performance stats, the effective spool up time, how long that is, how long it takes to ignite the engine and get the full thrust out of it. You've got the minimum throttle here. You've got how many ignitions. But down at the bottom of that tab here, we've got the configuration menu. Um, so that's our engine GUI. In this configuration menu, we can see all the future configurations of the engine based on what we have unlocked. So you can see this one needs post-war rocketry testing, and this one needs early rocketry. But one thing that you'll note is that look at these fuels down here. This is the fuel that it burns. If I switch to these different fuels, it burns the same fuel. However, if we go over to the Aerobee, it takes a different fuel at the very end. It takes helium. And one thing that you'll note is when you build these new launch complexes, each rocket needs a launch complex to work in um, realism overhaul. You need to have resources. So, for example, if I wanted to build a launch complex for this rocket, I need to have the fuel, which is alanine, and I believe, what is it? And a Furna. Hmm, somewhere down here. There we go. Yeah, you'll need these two fuels, but you also need helium, and helium is one of the fuels on this list as well. So one of the things that I like to worry about is whether or not I'm going to be able to use a launch complex for a certain amount of time without updating it, because updating it and building it, you can see it costs money. So it's important to keep that in mind. Anyways, to begin with, I'm going to make a simple rocket. This is going to be a U-1250 powered. Going to go down to a diameter, let's say a diameter of 400 meters or 400 millimeters. Not 400 meters, that would be quite a large rocket. We're going to give it a smooth cone. Let's go ahead and put the bottom size at 400 millimeters as well, top size at 0. And we'll go ahead and choose a tank type. We'll choose highly pressurized because the 1250 needs to have a highly pressurized tank, and we're going to fill it with its fuel. So now that we've filled it with some fuel, we'll note that the burn time is 11.6 seconds, and it has 982 meters per second of delta V. If we go into the GUI, we'll note that the rated burn time for this engine is 56 seconds. Now, what that means is that the engine can burn for 56 seconds guaranteed. It could burn over that, or it could burn slightly under that. But that is what the engine is rated to do. So we're going to go ahead and do a little bit under that just to demonstrate here. And we can go ahead and grab some little fins. Now this is just going to test it. This is going to show you how this rocket works. And our early rockets, you'll note, will more likely than not be uh, uncontrolled because a probe core costs a lot of weight to be controllable. So you'll note our sounding rocket is 0.7 tons. If I go ahead in here and I go 0.8, excuse me, 0.8 with a 100 EC, that's electric charge. Well, the probe core gets huge, for one, which we don't want. And um our weight went up pretty significantly for a probe core. We'll go ahead and go back and we'll go to, if we do the same thing with 150 charge and we'll resize, the weight of the probe core goes down. We'll note that the difference between these two, the science core and the near Earth, is near Earth is is controlled. So I could, in theory, operate fins if I had control flaps on it. And the science core is uncontrolled. And the main purpose of the science core is to do science. So if I go ahead and come on down here in this avionics GUI, we'll go ahead and put that up to 400. You'll note there's a little button that says configure experiments. So if we go through these experiments, you'll see we have 4 slots that we can put experiments in. I'm going to go ahead and put a barometer and a thermometer. Those are the only 2 experiments that we have unlocked at this time. So we'll just make sure that the other 2 slots are empty. We'll go ahead and put everything onto waiting. So in the base game, you'll note science is done instantly. Nothing happens. The science machine, the Kerbal doohickey opens and it takes a reading and it's instant. But we have a mod called Kerbalism that's part of Realism Overhaul, and it takes time to do our science. So we'll do a little bit of a simulation here just to demonstrate. We'll go ahead and grab a little launch clamp. This will not be our official launch vehicle, but we'll do a simulation just to show you how it works. So for example here, another thing that I would like to note is that, remember that engine spool up time that I told you about? The effective spool up time is 0.13 seconds. Now that's not a really long spool up time, but it can be really, really long if you're sitting on the pad, just not going up and your rocket is just sitting there waiting. So one thing that you need to do is give launch clamps in RP1, because if you don't have a launch clamp, your engine might not spool up in time and you might be out of luck. Your rocket may fall over, or even worse, it might just never get off the pad, because some engines don't work unless they are attached to a launch clamp and have the full amount of time to spool up before they're released. So we'll go ahead and hit that simulate button. This is a feature of RP1. It allows us to essentially plan out our rockets and prepare them ahead of time so we know if they're actually functional or not, before we waste any more of our time building these rockets, especially since with Kerbal construction time, it can take many, many days to build even one rocket. Now it is not daytime. I have made a silly error. Luckily, we're attached to a launch clamp, which should give us infinite resources, and our fuel should not boil off while we're attached to a launch clamp. So you note that while I'm attached to the launch clamp, I can use SAS, but as soon as I release myself from the launch clamp, SAS will turn off. It is unfortunately unable to be controlled. My fuel is all draining. And we're going up at a pretty nice clip. One of our contracts was completed. And we're getting a nice view of the Canaveral area. There's our shuttle landing strip, the Air Force landing strip, and then the Kerbal landing strip. This is a very short landing strip compared to these two. For that reason, when I do X-planes, I will likely be landing on those two. But back to the rocket at hand, you can see that the telemetry analysis, the pressure scan, and the temperature scan are all waiting because the science from low atmosphere and Kerbal Space Program RP1 has all been collected already. There is no science left to be collected from the ground or from the atmosphere in the low atmosphere. All the science that can be collected is above 40,000 kilometers. You can see that right here. And unfortunately, we will not be reaching that with this rocket. So in that case, we can do one thing. We're going to go on back to the editor. And I think we should add a kick stage, something that will just send us flying, get us going, because you'll note that we took off rather slowly with that rocket here today. We'll go ahead and add a decoupler, and then we'll add a little booster. This is a solid rocket motor. We're going to change the size of the decoupler. And we're going to put the launch clamp back on. We're going to check our rocket stability by going into the aerodynamic overlay and the center mass. It is stable, but it is not really ideal, to be honest. But that'll have to do for now. We want our center of lift to always be behind our center of mass in a rocket and in planes, but you would want it to be pretty far behind in a rocket. So we're going to go ahead and set up our staging. This little rocket booster you can see up in our Delta V tab is slated to burn for possibly 5 seconds, but truly it says only 1.1 second. So we're not going to worry about waiting to ignite our engine, because if you can note, there's something called ignition chance here. Ignition chance is something based on dynamic pressure in the atmosphere, whether or not the fuel is settled, and that goes up and down based on the level of engine that you have and whether or not it needs ullage and whether or not the atmosphere has too much pressure surrounding the engine bell. It could have so much pressure that the air is pushing back up into the engine and it's not letting it ignite. Or the fuel is flowing out of the engine faster than it can ignite. So those are sorts of things that you need to watch out for. In order to avoid that in this case, because we are just using a very short-lived booster, I'm just going to light the engine on top of it and drop it off as soon as we are ready. So I'm going to go ahead and simulate that. All right, we're out here. We're ready to simulate the rocket. You'll note that we've got this booster ready to go. Same thing, same stack. We're gonna go ahead and go ahead. Launch. Well, that was oopsie. We'll go ahead and restart the simulation. I have uh made one mistake with that. When you have a kickstart booster, such as like a Tiny Tim solid rocket booster, one thing you can do is you can actually put the launch clamp on the same stage as the rocket engines, because solid rocket motors need almost zero time to spool up. Let's see, does it even have a spool up time? No, it's instant. So that was a mistake. I probably could have just had it like this. We'll go ahead and try that again. There we go. We've dropped off the solid rocket motor. It gave us a pretty hefty kick. And now we're heading straight up into the great unknown. I think this time we'll get a little bit further than 40 kilometers apoapsis. Just checking it out, observing the surroundings, same thing as last time, seeing just how far we get. We're already getting close to our previous apoapsis, and we were going much farther now. This is the difference that a kick stage can give you. Boosters are important in RP1. Don't even waste your time if you're going to be getting off the launch pad at a small speed. We almost even made it to 100 kilometers off this first sounding rocket. Now that is impressive. So now that I know it's going to work, I'm going to go back. We're going to head back to the editor, and I'm going to spend some time sprucing this up. We'll try and make a pretty interesting rocket, and I'll be back to you once I've got my first sounding rocket. Alright, so welcome back. I cut out most of the build process because I felt like I would be really wasting your time with a bunch of time lapses. I'm trying to keep this to a low editing series, very little effort, um, so that way I can just get these tutorials out as fast as possible. But you'll know I changed the diameter a little bit. One thing that I thought about on the last one was the booster and the center core of our sounding rocket was a little different in size. I don't know if anybody else noticed that, but it was very apparent to me, and um, it made it look a little nubby, so I didn't really like that at all. So I went ahead and changed the diameter. It is now 300 millimeters and a longer length. Go ahead and make sure that all these are ready to go. I added some flags. Our new space program flag, it's a little bison over mountains. Our space program is generally designed to be very American in nature, but I thought something that would be unique and interesting would be to go for a more Native American feel. A lot of people go with those classical European scientists, or classical, maybe even Asian scientists for their launch vehicles, but I have yet to see really any Native American named launch vehicles out there in the world. So I thought that would be a really cool way to go. So I went ahead and I created the Aurora space program, which is supposed to be Native American in theme. And I went ahead and put the American flag since it's launching out of the United States. And I created the Chaska 1. So this is our first rocket. I'll give you a little bit of a rundown. We've got the main sounding rocket on the top with these procedural wings, something that I'll probably show you in another episode because we are running out of time here. Uh, they're very simple. You could note how we made these tanks earlier. You have all these sliders. These also have sliders. You just press the J button to access them. So we'll go ahead and close that, and Remove that. All right. You can also press the J button to close them. And then we've got the Tiny 10 booster as before. So the Sounding Rocket, the Tiny 10 booster with a little interstage that's got a cage, a lattice, so that way the rocket's gases don't try to destroy this booster and the rocket gases don't get trapped, which could cause combustion instability. On the bottom, we've got this nice little launch pad. Very simple, pretty elegant for a first launch vehicle. And on the side, we got the Chaska, and then we've got Aurora SP written on this side. And I thought I would get a nice little green paint job, just something very, very nice and easy. Chaska means I have it written up here for in case I ever forget. It is the name of the firstborn son in Sioux culture. So I was really interested in trying to create something unique. I wanted to come up with a good name that represents our first steps into the great unknown. So yeah, there's our launch vehicle. Next step in the tutorial, I'm going to show you how to build a launch complex. Once you have your launch vehicle made, if you go ahead and click New Launch Complex, it'll bring up this menu. This shows you how big your vehicle can be. It can't be over 1 ton. We'll go ahead and actually change this to Chaska LC for Chaska Launch Complex because this is where we're going to be launching most of our sounding rockets out of. You'll note that this vehicle cannot launch. It doesn't have its propellants. It doesn't have the. I guess it does fit within the parameters possible here, but it doesn't have a propellant. We can't fill it up. There's no place for us to fill up. So we have to build a launch complex. So I'm going to go ahead and do this. The maximum tonnage is 1. So we're at 0.9. That's above our minimum tonnage. If we brought this up, if we say did 100, see, we've got to have a minimum tonnage of 75. So for now, we're just going to leave it at 1. If we go ahead and up this, we're going to actually up it to 3 on both sides. That is the length and width when we're talking the cross beam here of this rocket. And then we can also up this height. I'm going to go ahead and up that to 15 so we have a little bit of wiggle room when we upgrade our launch vehicle, make it taller, and so on and so forth. We can also check this human rated button here. Human rated is just something that we will use later on once we get to our first suborbital vehicles and orbital class vehicles and so on and so forth. And you'll note down here the pad will cost 3,347 funds to build. It is going to cost a additional 125. I'm unsure where this comes from. I see. So I could duplicate this pad for the launch complex, and I could have more than one pad. So that way I could, once I have a launch complex available, I can, for 125 funds, I can add a second pad and I can have more than one rocket rolled out at one time. Then I've got the construction time estimated at 48 days, the yearly upkeep estimated at 489 funds with a daily upkeep of 1.3 funds. And I don't have any closest existing LCs. Commonality, same thing. It's similar to this, closest existing. The commonality is mostly used for when modifying an LC. It tells you how different the new one is versus the old one. And we've got a starting efficiency of 10%, which is how efficient our builders are when they're building our rockets. So we'll go ahead and build it. You'll note that automatically the resources for the rocket that you have selected are applied when you click New LC. We've got our kerosene and AK-20, and I guess there is no other resource. Guess what is the other research? Oh, nitrogen. Nitrogen is something that you automatically get when you make a launch complex. So that's another reason that we want to build with the U1250. All right, we'll go ahead and press build. We'll save this one more time just to be sure. And we'll go ahead and exit. Very soon we'll go ahead and wrap up this episode. The priority of this episode was mostly to get you through your starting contract selection and space program selection and whatnot. So we're going to go to this Space Center Management tab, the Kerbal Construction Time tab from earlier. It's down here. See, we have something new in our construction tab. It's the Chaska LC. We can up the work rate to 150%, or we can lower the work rate all the way down to 0%. These are the cost per day. If I go back down to 100, it's only 69 funds per day. And then I'm going to go ahead and hire some staff. So we'll just leave it at 100 for now. I'm going to hire 10 engineers. And then I'm going to hire 10 researchers. So that time I did it by clicking the hire button one time each. But if you hold the shift key and you hold over this hire button, then it hires 10 at a time. If you hold the control key, it hires 100 at a time. And so I'm just going to hold the shift key and hire 10 researchers. The reason I'm only hiring 10 engineers is, if you'll note back in the hangar, it said that you had a certain number of engineers possible for each launch complex. When I clicked human rated, it ticked up to 15. When I left it at non-human rated, it was at 10 engineers. So that is the maximum amount of engineers that you can have working at a launch complex at a specific time. The researchers here are going to start something different for us. While we let the Chaska launch complex construct, you'll note it's going to be done in 48 days on the 18th of February. We're going to go ahead on into the research and development building. The research and development tab is huge. We have a massive tech tree, and it goes all the way up to the 2020s. You've got some stuff even here past that. We're talking far future technology. But for now, we're stuck down here at the bottom of the ladder. We've got our very early rocket stuff. Something that we will need to focus on very early on is there's a couple tabs here. You will need this pre-war rocketry testing. This gets you your good engines like the RD100, which is a much better V2-like engine. It's derived from the early V2 engines, I believe, and it is one of the first Russian engines in production. And we've got some XLR-10, XLR-11. The XLR-11 is the rocket engine for the X1 and I believe the X2. And we got the XLR-41, which is an American version of the V2 engine, a derivative of that. We want to get this post-war materials science. This increases our launch complex efficiency by 3%. And it may not sound like much, but that is huge. That is really, really huge, especially early on when your complex efficiency is only 10% to start out, which means a 3% increase, that is a 33% increase in efficiency immediately. So, and then we'll need this early tracking systems. You can see here it's got our biological sample capsule, which is the experiment that we needed to do. After that, we've got the advanced biological capsule, which is the other experiment that we need to do for our suborbital research program. But for the beginning here, we're going to start off with this post-war material science. Since you start off with 2 science, I'm going to start with this so that way I can have access to better tanks. I'm going to also have access to the service module tank, which is intended to hold sounding rocket payloads, which we'll need for later contracts. We'll go ahead and pick that up. Now we're going to start researching it. It says that its estimated time of completion is going to be the 31st of August in 1952. Note, that is really far in advance. So we got to wait for a year for that. This can be increased by hiring more scientists, and I really recommend doing this, hiring more scientists. There is also another tab, so we can focus down here a lot. A lot of this stuff at this lower half of the tree is all based on capsules, space stations, that sort of stuff, and early satellites, and eventually planetary satellites that you'll see that NASA sends out nowadays. But up at the top of the tree, we've got these 2 lines. Now, these are what I am interested in for this playthrough. I'm going to try out and do some X-planes. X-planes leading into space planes, and I'm just going to see if I can demonstrate their capabilities alongside these traditional capsule launch vehicles. This is the supersonic plane development tab, and that will be one of the next ones that we're going to go for as soon as we have these 3 primary ones underway. Supersonic plane development is not the top priority since our contracts are all the way out until 1964. We're not in any rush to complete those. But now that we've got some science underway, we've got the Chaska launch complex, and our science is coming along nicely, then we are going to call this episode quits. We're just going to end it here. And next episode, I'm going to focus on showing the process of building those rockets. I'm going to show a little bit of the process of constructing your first airplanes. And hopefully I'm going to have my first launch and cross the Kármán line next episode. But that is it. This is the starting steps that we've got here. You're all set to essentially start your own program at this point, and everything from this point out is going to be independent, different for each save, I feel. Thank you for watching. This has been Inu Blue, and signing off.